6.4. This is day 2 of partial fraction decomposition, and let's get right into it. Here's the first question, and I want you to notice that there are two pieces to this, x minus 2 and this x squared plus 2x plus 4. So our first step is the same as before. We're going to write a over x minus 2 plus, and put a blank, and write x squared plus 2x plus 4. And you want to highlight this. This is new. This is what we call a prime quadratic. Prime quadratic meaning it's quadratic and it's not factorable. So this is it. This is as far as you can go. This is different from the last lesson, because in the last lesson we had things like this, which this is a quadratic, but it's factorable. So that's why it was really easy to work with. Our problems today are going to have prime quadratics. Now the way it works is, for this one we put a over x minus 2. So essentially we drop 1 degree down. So if this is like x to the 1 power, on the top you go 1 degree down. So it's ax to the 0, meaning we don't really put an x here. So for this one, if it's x squared, we're going to go 1 degree down. So bx to the 1. And you have to account for the possibility that there is a constant. So you put plus c. So that's our new part for today. So you need this, need with a prime quadratic. So these are the more advanced problems we'll be dealing with today. Luckily, the method is pretty much identical. You think about what each thing is going to need. So our first part, we can see that needs an x squared plus 2x plus 4, top and bottom. And our second part needs an x minus 2, top and bottom. And it's pretty much the same thing. We're going to take the numerator. So 3x squared plus 17x plus 14. That's going to be a times x squared plus 2x plus 4 plus bx plus c times x minus 2. Now we're just going to do some algebra. So 3x squared plus 17x plus 14. That's ax squared plus 2ax plus 4a. And that's going to be bx squared minus 2bx plus cx minus 2c. So pretty long. Now from here, we're going to equate the coefficients. So the exact same technique as last time. So let's highlight a couple things. So here's my x squared. I have an ax squared and a bx squared. So a plus b should equal 3. Okay, 17x, and I have a 2ax, a 2bx, and a cx. So that's going to be 2a minus 2b plus c. That's equal to 17. And I'll circle the numbers here. So that would be 4a minus 2c. That's 14. And at this point, so we're going to solve this by hand. And notice how we have 3 variables of 3 equations. So this is very doable. Let's label this E1, E2, and E3. Now I'm going to use E1 and E2. And the reason for that is because I'm looking at this B and 2B. That's going to be really nice to work with. Because I can see if I do 2E1 plus E2, I can see that the B's will cancel. So let's try that. So 2E1, that's 2A plus 2B, that's equal to 6. E2 is 2A minus 2B plus C, that's 17. If I add these, I get a pretty nice equation. 4A plus C, that's 23. And that's going to be equation 4. And now look at this. I have something pretty nice. Equation 4 and equation 3 work really nicely. I can just say equation 3 plus the negation of equation 4. So let's rewrite equation 3. The negation of equation 4, it's negative 4a minus c is negative 23. Now we get negative 3c, that's equal to negative 9. So c must be 3. Okay, now we back substitute. If c is 3, I can see a must be 5. And if a is 5 here, b must be negative 2. So we did it. Let's plug it all back in. So 5 over x minus 2 plus negative 2x plus 3. And that's over our prime quadratic. And there's our answer. Now let's try a little harder one. Notice how it says find the partial fraction decomposition, and highlight this, a repeated quadratic factor. Which means the bottom should be easy, right? That's x squared plus 1. And I know now to put ax plus b. And the second part, this is the tricky part. You have to put the repeated factor. So x squared plus 1 squared. And this is the key. Even though this thing is squared, the heart is a prime quadratic. So you still consider this a prime quadratic, even though it's being squared. You're focusing on what's inside here, which means the top is going to be cx plus d. Now, at first glance, this looks like it's going to be very challenging, right? Because look at how crazy this is. But if you really think about it, when you create the common denominator, this thing is actually done, right? Because this is your common denominator. The only thing that needs to happen is that x squared plus 1 to the top here and the bottom here. So let's do that. We're going to FOIL it. So let's FOIL it right now. That would be ax to the third plus ax plus bx squared plus b plus cx plus d, and that should be your numerator, which is 5x cubed minus 3x squared plus 7x minus 3. Now let's take a look at our comparisons. Here's my x cubed. There's only one other x cubed. Look at that, that's really nice. That means a must be 5. Now let's look at another one. My x squared. There's only one other x squared, look at that. So b must be negative 3. Let's do another one. I have an ax, a cx, and a 7x, so that would mean a plus c should equal 7. And I'll circle the constants. So b plus d, that should be negative 3. But take a look at this. We have a is 5 and b is negative 3. If a is 5, you know c. C has to be 2. And if b is negative 3, and b plus d is negative 3, d should be 0. So we solved that pretty quickly. Now we plug it back in. So that's going to be 5x minus 3 over x squared plus 1 plus 2x over x squared plus 1 quantity squared. And we're done. So not too bad. Now here's the last one. It says find the partial fraction decomposition using the Heaviside method. So what we've been doing is this, equating the coefficients. That's what this method is called. And I'll highlight that here. There's actually another method called the Heaviside method. So I'm going to show you that right now. It starts the same way. So no matter what, you can't really avoid this initial setup. And then we're going to do the same thing. ax plus 2 plus bx minus 4, that's equal to x plus 14. But what the Heaviside method is it's a shortcut if you have like simple unique factors like this. So notice how these are both unique and they're pretty simple. What we're going to do is a substitution. We're going to let x equal -2. Now by doing that, look what happens. If I plug in -2 here, this eliminates itself. So I get b, plug in -2, that's equal to -2 plus 14. And I get -6b should equal 12. So b is -2. So by plugging in the value for x that's convenient, I was able to solve it pretty easily. And to get the other variable, I'm going to let x equal 4, because I would knock this thing out. And now I'm going to get a times 4 plus 2 should equal 4 plus 14. So 6a should equal 18. So a should equal 3. So the Heaviside method just lets you kind of do a shortcut on the algebra. So my answer must be 3 over x minus 4 plus -2 for x plus 2. But again, this method is only good when the factors are unique and the problem's quite simple. You wouldn't want to do it on a more challenging question, like something like this or like this one. You could, but I just don't recommend it.